Welcome to the composites world. I consider AIrtech as a big player in the composites and the main composites world. And thanks to them and thanks to my curiosity, I consider myself one of the pioneers in the modern composites technology and especially manufacturing technology. So today, for the next half hour, I hope, I will be working for AIrtech, showing you AIrtech products, but my mission is being, hopefully, a teacher. I started in Turkey teaching in 1991-92 at TAI, and it's been working so far. But in reality, I started teaching composites back in July 1983. So when I was asked to be a salesman for AIrtech, I said, I can never sell anything. If you want to use me as a teacher, here I am. If not, forget it. And so far, as a teacher, talking to people, helping them, choosing the proper products to do the proper work, the least expensive way and the easiest way without or avoiding repairs and scraps, I've been successful. So I can work good as a teacher, but I'm a bad salesman, okay? So if we're thinking of going into the composite business, as I did 40 years ago, back in 1972, it's 45 years ago, I guess, you need to have a project. If you go into manufacturing composites, at least the basics, or for the basic way, you need molds, because you need to shape your composite part. Today are modern ways of doing that without the mold, but you still need a mold for the most part of it. And then you need to choose your products, whether you go infusion or wet layup, or you go to the marine, or you go to the windmill business, or the bulletproof, or the aeronautics, or the simple space. You're gonna need to be organized, and you need your materials, you need your projects, and you need your molds. And once you have your molds, you decide what type of layup you're going to have, what type of structure, and then this is where I am here to talk about auxiliary materials. People sometimes think auxiliary materials are not important. They're just something that they put in there. We cannot spend money on that because it's to throw away. It's not important. The problem is that when your director asks you why you lost parts, you lose time in production, you're going to say, well, I try to save money in auxiliaries. But the auxiliary materials are the only reason you can make a perfect part. Without it, forget it, okay? I can tell you, or you can tell me that you can make parts without bags, without infusion, without this, without that. The average airplane today flies with composites that are made mainly with bags, with auxiliary materials, with a mold, with vacuum and pressure and temperature. Okay? Those are essential to make composite parts and to make good composite parts, flyable composite parts. If you look into the marine areas or into the windmill areas, wind energy, the philosophy is the same. You still need a mold, you still need auxiliary materials. Okay? So, if we turn to AIrtech, they are the main players in making auxiliary materials. In fact, they are the only company in the world that produces and puts at your door the materials. Okay? This is where I started. Back in 1991, this place was a tenth of what it is now, and that's six people. I was number 7, okay? Today is 200, and that's 15,000 square meters of production area. I must have done something. I don't know what, but something, okay? And I try never to be a salesman, never. Here they produce backing films. They produce everything, but we start with backing films. And here I come to the teaching point, and I hope one day you come across this area and you say, David was right. You can spend 50 cents a square meter or $15 a square meter, and you can do the same job. So please prepare yourself before you tell your director that you have a budget to make composite parts. It's very important. You need to look into the temperature your system is going to require, the process, whether it is infusion or autoclave. You need to look at your resin systems, if you need chemical resistance or not, and of course your temperature. Those are the 3 areas that you need to look at it before you choose where you're going to spend your money. And as I say before, you can equally make a mistake by going too expensive or going too economical. So you need to know what you're looking for. If you go into the internet and look at any site on composites, whether it is infusion or composites overall or AIrtech, you will find lists and lists of material, videos, applications that you can self-teach yourself how to make composites. But it is important that you know which film you're going to have. We have films, or AIrtech produces films from just nylon, narrow, wide, high temperature, low temperature, multi-layer. One more. Huh. One more? Okay. Can find it. Today, we can build films of 1 layer, nylon, pure nylon, nylon 6. We can build the same sheet of nylon, much more resistant to dry weather, humidity accumulators, nylon 6/6, or you can go into nylon 6/6. But with today's technology, we have what we call multi-layer or secure lawn. AIrtech has 3 or 4 different families of nylons. They started with Ritelon back in the 70s. Then they went into Iplon, humidity resistant. Then secure lawn, and then stretch lawn. Each family has different applications, and each application can do the same job. So it's up to you to know exactly what is required for your job, and obviously you need to practice. You cannot make $1 million part overnight. You need to take it step by step to get in there. So if you work in the desert, you obviously cannot work with nylon 6. So you have to go to a more stretch film. And if you work with a very chemical aggressive resin, your best idea is to go with a multi-layer film. A multi-layer film means can be very strong, can be very high temperature resistance, and can be also chemical resistance. As an example, in the phenolic resins, you need a chemical resistant film, otherwise it just burns your bag and you lose your part, okay? You can also, if it is just for an experiment, instead of spending a lot of money, you can protect your bag with a special film, release film, for instance, a film that is used to separate the resins from your auxiliaries. And if you do a good job, you can seal your resin inside of this release film, and then you can use it cheap or economic bagging film. But again, you need to do your homework. The same film nowadays, and I'll give you an example why this happens, can be corrugated. This is a bagging film corrugated. Why corrugated? You imagine put on a compaction bag in a Airbus 350 or Boeing 787 wing. It's a long bag, 35 meters. And you have to do this several times. So they eliminated all the auxiliaries from this compaction package, and we created this self-vacuum bag. You just apply it and the air passes through the corrugation, and that's your automatic compaction bag. And when it's done, you put it aside and use it next time. It's called corrugated bagging film. In this case, it's called Air Draw 2, has a special name, but it's not as important as knowing what it is for, okay? These are the release films I was discussing. These are typically chemical resistant films. They're not used for bagging. They're not resistant of pressure. They're just release films. They are part of the package of your parts composite layup. This is typically the first sheet that you apply when your lamination is finished, so that when you finish your part, your bag and your auxiliary, your breathers can come up released from this film. Next. This is the same family of films, only lower price and lower temperature. The previous sheet, you can use those films up to 260 degrees C. This one, you can only go to 120, 130 cures. It's good for infusing a big boat, or for a windmill blade, or wind energy blade, okay? You would not use this film to make an aeronautic part, because you lose your part. It doesn't take the resistance. It will melt into your part. But you would not want to use the previous expensive film on a wind energy blade because of the cost. Okay, this is less than half of the other film as far as cost, and it does the same job. Okay, in fact, in some areas does a better job than the other film because it's a little stiffer, and people like it because it's stiff and removes out very quickly. Okay. Now, here is something that a lot of people break their nose with. They figure, okay, I want a perforated film. Sure. This little table here can save a lot of people many headaches, because if you have the wrong perforation, you can take too much resin and your part gets dry and gets lost. Or you can have little perforation and you have too much resin and your part is too high, too heavy, and it doesn't pass. Okay? So it is important that you know the thickness of your part, your cure cycle, and your resin content as well as viscosity. If you do an infusion with a film that has too little perforation or the perforation is too small, you'll have the part perfectly wet and you look at it and a beautiful part. But the next morning when you take it out, the lower plies are dry because you wet it nicely, but it didn't penetrate all the way down. If you have too much, what happens is you're gonna flood your lines and you're not gonna wet your part. It's gonna travel too quick. So the ideal situation is to have, obviously, you go to your catalogs, you call your supplier, but this isn't the idea. If you don't do that, you break your nose, like I did many years ago, and I still talk to people today that they do break their nose because composites is a technology that you only perfect with time. There is no such thing as making an infusion the first time and be perfect. I cannot do it after 40 years. You need to start with a little infusion, learn from it, observe where your resin goes, or where you need to put your barriers, where you need to stop it, where you need to accelerate it, where you need to bring it faster, or to your specific thicker areas. I remember the first time I built a boat by infusion. It was in France maybe 20 years ago, and I look at the design of this boat, and around the keel area was 10 times the thickness of the rest of the boat. And I say, what am I going to do here? So first, I have to forget the boat and infuse the keel area. Otherwise, I'm going to have the boat full of resin and the keel will be dry. You know, half hour after I started infusion, I see that the resin doesn't get off the pit. I mean, this took more resin than the rest of the boat. So I already had some experience, and I directed my tubes. In those days, there was no new technologies. So I directed my tubes right around the keel area, and sure enough, it went right down, penetrated all the way down, and it was totally wet before it got into start going into the boat. So after the resin stayed right in the keel area. It was a good decision. I could have broken my nose, but this is how you learn. This is how you learn. Obviously, with time, you pick up new materials, you pick up new things, new ways, new pressures, new directions, many different things that you can put inside the bag to help you redirect the resin wherever you want. Wide formats, this is just, again, it's up to you to use what's available. Luckily today we have many more different things than we had 10, 15 years ago. Today you can order 12-meter wide film without joint. 10 years ago, you want 12-meter wide film, you need 2 joints, 4 meters, 4 meters, and 4 meters. This is extremely dangerous when you have a line with sealing tape with wrinkles inside of a boat or in a big part, and you walk on top of it. Extremely dangerous. So today, luckily, people have developed very wide films and helps us making parts with less headaches. Okay? Next. Of course, I'm not going to talk about the tapes because there are so many in the market. You can choose from nationalities, color, specifications, you name it, unless you're in the aeronautic business. There, you cannot get away with what you want or the price or the company. It is in your QPL, in your recipe, and you got to use it. Next. Another thing that AIrtech does well, did it for many years, I never got too involved. Lately I am. In fact, this week I'm in Turkey because of this material, which is required for the new modern or lately designs for the fighter that is made here at TAI for Turkey, the F-35. It's a line of prepregs to make molds, okay? They have for different temperatures, different applications, different costs, and different resins, okay? The resin I have used lately at TAI, it's called benzoxazine. For those of you that never heard, it's a new resin for prepregs that are not available yet to make parts. I would say within the next 5 years, I hope. This is a specific resin, different from epoxies. You will not require freezers. For those of you who know what a freezer costs for prepregs, okay? And the out life of this prepreg is 6 months, okay? I would say these are the two main differences on this prepreg. Okay, it's no freezer required, no dry ice to food transportation, and 6 months out life. So I have done one of these tools at the TAI this week, and hopefully this will be known throughout Turkey in the next few years, and hopefully we get the aeronautic production prepreg approved, I hope, within the next 5 years. If you have any questions about composites, manufacturing, or anything else in composites, please come see me, see Nurettin, call us. We are available. Thank you.